ESA researchers built a plant that can extract oxygen from the moon with an abundance of moon dust. We could see a sustainable habitat built on the moon within our lifetime. The final frontier. European scientists are hoping they can send an oxygen plant to the moon for a sustainable long-term mission. The facility would convert moon dust into breathable oxygen for the settlers. The mission is still quite far out, but the team hopes to have a viable demonstration of the technology by the middle of this decade. European Space Agency, ESA, researchers have begun extracting oxygen from simulated moon dust. A reclamation plant has been built at the European Space Research and Technology Centre, ESTEC, in the Netherlands that can remove and harness oxygen from lunar regolith. The process leaves behind a mixture of metal alloys, which might also be recycled. The ESA envisions the oxygen and leftover byproducts being used by lunar settlers. Simulated lunar soil before, left, and after, right, oxygen extraction. Having our own facility allows us to focus on oxygen production, measuring it with a mass spectrometer as it is extracted from the regolith simulant, notes Beth Lomax, lead researcher from the University of Glasgow. Being able to acquire oxygen from resources found on the moon would obviously be hugely useful for future lunar settlers, both for breathing and in the local production of rocket fuel. While the researchers currently use simulated regolith because of the rarity of actual samples, tests with small amounts of returned moon dust show that it is made up of about 40 to 45% oxygen. It is, in fact, the most abundant element in the material, but is chemically bound to oxides. The extraction method, called molten salt electrolysis, superheats the dust to break the oxide bonds. The regolith is placed in a container with molten calcium chloride salt, which serves as an electrolyte. It is then heated to 950 degrees Celsius. The dust remains solid at this temperature. Then electrical current is run through it, separating the oxygen, which flows through the salt and is collected in an anode. The method is not novel. It was developed by UK-based Metallicis for metal and alloy production. However, in that capacity, oxygen was an unwanted byproduct that was released instead of collected. In this instance, the alloys are the byproduct, but ESA research fellow Alexandra Maurice mentioned that they are also interested in what they could do with the metals. The production process leaves behind a tangle of different metals, said Maurice. And this is another useful line of research, to see what are the most useful alloys that could be produced from them, and what kind of applications could they be put to. The current harvesting plant expels the oxygen as CO2 exhaust. For more on this story, visit the news article link.